Hypothesis testing is a crucial tool in statistics, allowing us to make informed decisions based on data. We start with two hypotheses: the null hypothesis, which suggests no effect, and the alternative hypothesis, indicating an effect. For large samples, we typically use the z-test to compare means, while for smaller samples, the t-test is our go-to. When assessing variability, the chi-square test helps us analyze one sample's variance, and the f-test compares variances between two samples. Proportion tests, often used in market research, utilize z-tests to determine if the proportions differ significantly. Remember, always check your assumptions and leverage statistical software for complex calculations. Understanding these concepts is key to mastering hypothesis testing. Hello, everyone! Today, we are diving into an essential topic for MBA students and research scholars: hypothesis testing. By the end of this video, you'll understand how to perform hypothesis tests for large and small samples, including mean tests, standard deviation tests, variance tests, and proportion tests. We'll also cover both one-sample and two-sample tests for independent and paired observations. Let's get started. Hypothesis testing is a statistical method used to make decisions based on data. The two main hypotheses are null hypothesis, H0, assumes no effect or no difference. Alternative hypothesis, H1, assumes an effect or a difference. The steps in hypothesis testing include formulating the hypotheses, choosing the appropriate test, calculating the test statistic, determining the critical value or p-value, making the decision, reject or fail to reject, H0. Now, let's explore specific tests. For testing means, we use different tests depending on the sample size and whether the population standard deviation is known. One sample. Mean test, large samples, sample size greater than 30. Use the z-test. Formula: z-test equals the mean of the sample minus the population mean divided by the population standard deviation divided by the square root of the sample size. Small samples, sample size less than or equal to 30. Use the t-test. Formula: t-test equals the mean of the sample minus the population mean divided by the sample standard deviation divided by the square root of the sample size. Two-sample mean test. Independent samples equal variances. T-test equals the difference between the means of the two samples divided by the square root of the pooled variance divided by the sample sizes. Unequal variances. Apply Welch's t-test. Paired samples. T-test equals the mean of the differences divided by the standard deviation of the differences divided by the square root of the sample size. Now let's look at tests for variability. One sample variance test. Use the chi-square test. Formula: chi-square equals the sample size minus 1 times the sample variance divided by the population variance. Two-sample variance test. Use the f-test to compare variances of two independent samples. Formula: f-test equals the variance of the first sample divided by the variance of the second sample. These tests are especially useful when analyzing process stability or comparing variability between two groups. Proportion tests are common in business scenarios like market research or quality control. One sample proportion test. For large samples, use the z-test for proportions. Formula: z-test equals the sample proportion minus the population proportion divided by the square root of the population proportion times 1 minus the population proportion divided by the sample size. Two-sample proportion test. Compare two independent proportions. Formula: z-test equals the difference between the sample proportions divided by the square root of the pooled proportion times 1 minus the pooled proportion multiplied by the sum of the reciprocals of the two sample sizes. These tests help answer questions like, is the proportion of satisfied customers different between two regions? For every test, compare the test statistic to the critical value or use the p-value. If the test statistic falls in the rejection region or p-value is less than the significance level, reject the null hypothesis. Let's quickly go through an example. A company claims their product's average lifespan is 5 years. A random sample of 40 products has a mean of 4.8 years with a standard deviation of 0.5 years. Is the claim valid at a 5% significance level? Solution: since the sample size is greater than 30, we use the z-test. Z-test equals the sample mean minus the population mean divided by the population standard deviation divided by the square root of the sample size. Z equals 4.8 minus 5 divided by 0.5 divided by the square root of 40, which equals negative 2.53. Critical value at a significance level of 5% is negative 1.96. Since negative 2.53 is less than negative 1.96, we reject the null hypothesis. To summarize, use z-tests for large samples and t-tests for small samples. Variance tests include chi-square and f-tests. Proportion tests are z-tests for large samples. Tips: always check assumptions before applying a test. Use statistical software for complex calculations. I hope this session clarified your doubts about hypothesis testing. Thank you for watching. Don't forget to like, share, and subscribe to Chandrasekhar Research Academy of Business Studies. See you in the next video.